All right, guys, so we've been talking about even and odd functions. So the past couple of days, we've been looking at graphs and how to determine if the function is even, odd, or neither. So this first page is just kind of going through just a reminder of how to do that with the graphs. So we have even functions, the y-axis acts like a mirror. So we have this right here, and then odd functions, remember, it's symmetrical around the origin. So that means if you flip the paper upside down, it looks the exact same. So today we're going to look at how do you do this algebraically. So if I did not give you a graph and I just give you a function, just an equation, how could you figure out if it was even, odd, or neither? So that's what we're going to go through today. All right, so this part down here, this is explaining how we do that. So algebraic test, so we're going to substitute in negative x, so it's really important, for x everywhere in the function, and then analyze the results. And so if it's even, if I plug in negative x into the equation and I simplify it and it's even, that means if I plugged in negative x, I would get back the exact same function I had in the beginning. And then if it's odd, that means that every single thing in the equation has flipped signs. So everything is the opposite, and that's what this means right down here. So if I plug in negative x, then my whole entire function has flipped signs. Okay, so down here at the bottom, these are 3 examples. Okay, so on the first one, our original is x squared plus 4. So I replace x squared with negative x. So let's think about this. If I have a negative x squared, so let's throw a number in there. If I have negative 2 squared, that means that that is negative 2 times negative 2. Anytime you have a negative times a negative, it turns it positive. So that's why this turned into just x squared. So no matter what the number is, if I have a negative x in there, if I turn that number negative, then if I square it, it automatically gets rid of that negative. So that's why we're back to x squared. Now, obviously, there's nothing I did with the plus 4, so that just comes straight down. Now, what we have here, this right here, x squared plus 4, we compare that to the original. Now, is it the exact same? Is it the exact opposite? Or is it neither one of those? And so if you look at this, we have x squared plus 4 here, and then we also, our original is x squared plus 4. So we got back, even when we put in a negative x, we got back to our original function, and that's what makes it an even function. All right, so let's look at if it's odd. So we're going to start off doing the exact same thing again. We are going to plug in negative x for all of the x's that we see in our original equation. So we have x cubed minus 2x. So if I put a negative x cubed minus 2 times negative x. So we're going to simplify this. Now, think about this. If I have negative 2 times negative 2 times negative 2, right? That's negative 2 to the third. So a negative times a negative turns a positive, and then times another negative would make it negative. So right here, negative x cubed. Okay, so if you have a negative number and you square it, it's going to turn positive. If you have a negative number and you're going to cube it, it turns it negative. All right, because it all has to do with the number of negatives that you're multiplying. All right, and then we have here we have negative 2 times negative x, so that turns into plus 2x. All right, so now let's look. Let's compare what we got. Yeah, let me get rid of that so we can see it again. So let's compare what we got. Right here is our answer. Once we plugged in negative x, we got negative x cubed plus 2x. Compare that back to the original equation. Notice that we did everything has turned opposite. So our x cubed has now turned negative, and our negative 2x has now turned positive. So everything has flipped. So that's what makes it an odd function. Every single thing has flipped. All right, so then let's look at an example of where it doesn't do either one of those two things for even and odd. So here we have x squared minus 3x plus 4. We plug in a negative x for all of the x's that we see. Negative x squared, if it's to the second power, then it's going to turn a positive. Negative 3 times a negative x turns into a positive 3x. And then the plus 4 just stays. So now if you look at what we ended with, so here's what we ended with, right? So if we compare this back to the original, all right, so we have x squared and x squared, so they stayed the same. But look at the middle term. This became negative 3x and this became positive 3x. And then, of course, we have the plus 4, which stayed the same. So two things stayed the same and one thing turned opposite. So everything didn't stay the same and everything didn't turn opposite. So therefore, this is neither. It can't be either one. All right, so we're going to practice some of this. All right, flip onto the other page. So this top part. So a function is an even function if f of negative x, so we're plugging in negative x into the function, and we get back our original function. Okay, so a function is an even function if f of negative x equals f of x. So if I plug negative x into the equation, I will still get back to my original equation. It'll look the exact same. Now, look at this star right here. It's telling us the right side of the equation of an even function does not change if x is replaced with negative x, meaning nothing changes. All right, even functions are symmetric with respect to the y-axis. We've already talked about that. All right. Okay, so we're going to keep going. All right, so this means that we could fold the graph on the axis and it would line up perfectly on both sides. So we've talked about that. All right, a function is an odd function if when we plug in negative x, everything flips. So this is a negative f of x. Sorry, that doesn't look right. So I want to emphasize that we put a negative in front of there. So that means everything flips signs, okay? So again, look at the star right here. Every term on the right side of the equation changes signs if x is replaced with negative x. And then yesterday, or the couple days ago, we talked about odd functions are symmetric with respect to the origin, right? The point 0, 0. This means we can flip the image upside down and it will appear exactly the same. Okay, so now we're going to do some work. So on your own, you guys are going to classify these graphs as even or odd or neither. So you can come back to that. Okay, so flip on over to the next page. All right, so now to verify algebraically if a function is even, odd, or neither, we must prove one of the following. For even, we have to prove that if we plug in negative x, we have the original. And for odd, if we plug in negative x, everything flips signs. Okay? All right, so here is our example. So we have this equation, and we're going to kind of follow this through, and we're going to see what happens. Okay? All right, so this is our original function. So plug in a negative x for every x and simplify. So instead of x squared, this becomes negative x squared plus 3 times negative x plus 5. All right, so negative x squared becomes x squared. 3 times negative x becomes negative 3x, and then plus 5. All right, so let's compare this back to our original. So if we compare this back to our original, does it stay the exact same? It does not, so therefore it can't be even. So then this is asking us to do the exact same thing. So here again, this is our answer. Go back to the original. Is everything flipped? Well, we have x squared and x squared. We have negative 3x, but now it's a positive 3x, and then we still have a positive 5. So again, only the middle term flipped. So therefore, this is neither even nor odd. Okay, so let's do a couple more examples. So I'm going to plug in a negative x for x. All right, remember, anything raised to an odd power, it's going to stay negative, or whatever sign it started with. So this right here, negative x to the third, remember it's negative x times negative x times negative x. Negative times a negative is positive. Positive times a negative is going to be negative. Okay, so here this is negative x to the third. Negative 6 times negative x becomes plus 6x. So we look, so this is what we got. Go back and compare it to the original. Did everything flip or did everything stay the same? So if you look, everything flipped. It's now a negative instead of a positive, and now this is plus instead of minus. So this is an odd function. All right, flip to the next page. Plug in negative x for x. All right, so negative x to the fourth. Remember, that's 4 of these. So a negative times a negative is positive, times a negative is negative, times another negative turns out to be positive. Remember, if it's raised to an even power, it's always going to be positive. If it's raised to an odd power, it's always going to be the opposite of what it was. Or it's going to be negative, I'm sorry. So here, this would become just x to the fourth. And then negative 2, all right, let's start this. We're going to do our exponents first. So negative x squared just becomes x, because that would be negative x times negative x, which is a positive. So this just becomes minus 2x squared, right? So no matter what. So now if we look at it, what has happened here? So we have everything has stayed the exact same. We still have x to the fourth minus 2x squared, which is what we had originally. So this is an even function. Okay, number 3, plug in a negative x. All right, go ahead and pause the video, test that out, and see what